Broadcasting live. It's America's longest running talk show on computers. It's Computer America, bringing you the biggest names in technology with guest interviews, new products, and your emails. Listen live at computeramerica.com on any device around the world. Email the show at live@computeramerica.com or find us on social media. Be sure to check out our website for contests, giveaways, show notes, live video stream, podcasts, and more. You're listening to Computer America.
Hello and welcome everyone into the Computer America Show. We are the nation's longest running, nationally syndicated radio talk show on computers and technology. And everyone, welcome into the program. I hope that you're doing well and you are ready for today's program. Because today on the show we have, of course, the one, the only Mr. Ralph Bond. He'll be joining us here to talk all about, well, science and technology trends. And if that's a little enigmatic, that's okay. Ralph's going to come on here in just a moment and talk about, what exactly it is that we try to do on these segments. But the gist of it is they're stories that you probably have not heard of, you definitely want to hear of, and they're going to be on the positive side. Because, hey, this week it's been crazy, but, always like to end the week on a segment such as this. So with that being said, computeramerica.com, that's where you'll find everything, including past shows, future shows, show notes, articles, and of course, you can see as well Ralph's segment. So at the top, we have, of course, the navigation bar. Most of them don't lead to dead pages just yet, but the third one there is Ralph Bond. If you click that, you can find his most recent program as well as past show notes. Show notes are super important. You're going to want to check those out either by watching the video or checking them out yourself at computeramerica.com. So with all that being said, let's go ahead and bring Ralph on and just have fun with it. So he has been a longtime Computer America contributor and of course has turned into our science and tech trends correspondent where we cover a variety of topics and we love having him on. So Ralph, welcome back onto the program. How you been?
I'm doing great. And folks, if you're new to the show, welcome. Let's explain a little bit more about what we're going to do. Each Friday, Ben and I look at 4 recent articles that show us key trends and developments in a host of things. Artificial intelligence, of course, robotics, medical technology, sustainable energy technology, transportation advances, agricultural tech, space research, physics, you name it, all across the board. But most important of all, we're going to give you an oasis of positive news thanks to the world of science and technology.
Absolutely. And just because things just don't always work just right, I'm going to try to edit this on the fly. But Ralph, that's a great introduction, and we'll go ahead and jump into the stories. And again, the show notes, you can follow along because by the time that you hear this, you will be able to follow along in the show notes as well. But we're going to, of course, start with story number 1. And yeah, let's talk about, speaking of a trend, mushrooms. They're not just what's for dinner, and it's pretty hit or miss there. But, in the world of fabrics, textiles, when it comes to renewable energy resources, mushrooms have a lot of promise, not the least of which, surprisingly, is, well, construction. So let's talk about story number 1.
Yes, you're so right. And there is a trend, and we're going to talk about this a lot. This story, though, first one comes from CNN, and it's fungi, or for our British friends, fungi, could be used to build homes one day, or other structures too, of course. And this is really fun. And what Ben's alluding to over the past several years, there's been multiple stories where people are making leather replacements out of mushroom materials. And so good old mushrooms turn out to be these amazing things in terms of their structure and how they can be repurposed for things that just really are quite surprising, including in this case, a building material. So let's get into the story. This article discusses a groundbreaking study in which researchers are exploring the use of living organisms to create sustainable building materials. That's the key sentence here, and that's the key trend. Using living organisms to create sustainable building materials. It's such a freaky idea, but it's just fascinating to me, at least anyway.
It's freaky, but at the same time, that's wood. That's something that we've been building.
Sure, of course,
forever. So, but not using wood and using mushrooms, that's a crazy idea.
Well, yeah, and the crazy twist is the keyword living organisms.
True,
Okay.
true.
And this is what's so fun about this story. So here we go. In the study, a team from Montana State University developed a novel composite material by growing a dense network of fungal mycelium, specifically from, and I'll try to say this without butchering it, the name of this mushroom, okay, Neurospora crassa, and then introducing the bacterium Sapporo Sarcina pasteri. Good Lord. Come
Sounds
to the
good to me.
show notes. Come to the show notes and read this because I'm butchering it, I'm sure. So what they did is they took this mycelium and a bacterium, and they combined them together to create this dense network of fungal mycelium structure. So they're combining these two things together. That's the key. And as noted in the team's research paper, quote, we created a biomineralized, engineered living material using mycelium scaffolds from that Neurospora crassa that were mineralized either by the fungus itself or by the bacterium that they introduced, that Sapporo-Saracina pasteri. And the biomineralization process produces calcium bicarbonate, which hardens the soft, spongy mycelium into a rigid bone-like structure. Okay, so get it? You take the mushroom, you take the bacterium, you combine them together, it creates this biomineralization process, which in turn hardens it into a bone-like structure. Wow,
Which,
pretty amazing.
yeah, for those who are able to see the video and you can kind of
Right.
see the the headline image there from the research article, it looks like trail mix. It looks like packs of ramen and these blocky materials.
Yeah.
But yeah, I guess we're going to talk about I'm sure further on just how how strong this stuff is, but it's very moldable, very shapeable, I guess.
Yes.
Right now they just have cubes, but of course, I'm sure you could do beams and other structures. So it makes a lot of sense.
Exactly. It is funny. In fact, looking at the image, one of them looks a little bit like a Triscuit cracker.
True.
So this innovative method hints at the possibility of constructing load-bearing, self-repairing buildings in the future, offering an environmentally friendly alternative to conventional cement-based materials. There was a key thing in that sentence I just read from the article, self-repairing buildings, because we're talking about making a structure out of living organisms. Okay, let that sink in. This is the part that's so fascinating. The research is particularly significant given the environmental impact of traditional cement production, which accounts for about 8% of global carbon dioxide emissions and is a major contributor to climate change. So again, this effort on the part of Montana State University and researchers around the world to look for alternatives to concrete has to do with climate change and the impact of cement. So can we find viable alternatives? And while the technology in the case of what Montana State University is doing is still in its early stages and won't replace concrete overnight, the study establishes an important proof of concept. And I'm going to stop for a second, Ben. One thing new listeners, you'll need to find out right away is that a lot of what we talk about on Friday is early research, twinkle in the eye research that may have implications for the future or may not. It's experimental. And so that's why it's trends is the big theme for most of our stories every Friday.
Absolutely. And I really like this one because even if you can't, and I don't know why, whenever I think about construction like this, I think of houses. But even if you can't build, straight up houses, you could build other infrastructure, maybe that, that you would traditionally use concrete for, even if it's something as simple as like a bench or, a small little retaining wall or something like that, something small that you could just replace a few things away from concrete to this stuff,
right.
that would still make a huge impact.
Yeah. And to wrap things up here, a little conclusions, a sentence from the article: by combining living fungi and bacteria to produce a self-strengthening material, the work opens doors to engineered living materials that could eventually deliver properties such as self-healing and environmental remediation. So this is one of the most interesting uses of mushrooms I can think of.
More interesting than what I do with them, which is nothing good, I promise. It's Ralph, like It reminds me of the story that we did about the self-healing concrete, where that one was fun because they had like,
Yes,
fungus, or they had some kind of cells in them that, were trapped in the concrete. And then when it cracked, as concrete wants to do, and the moisture got in, the moisture reactivated it, and then it kind of grew and
exactly.
expanded and rehealed itself. It probably something very similar here. And
Yes.
yeah,
Yeah. Yeah.
I'm sure a lot of people notice little hairline cracks in their houses and their roofs and the walls, and they're like, man,
Foundations.
yeah, I wish those would just heal themselves, and maybe one day they will. So, I,
Yeah.
I'm kind of curious of, like, they're showing rigid structures, which is all, kind of well and good. We've done a lot of stuff about 3D printing. I wonder if this would be a viable thing. Like, even if you don't replace
Oh,
concrete with it, what if
yeah.
you could find ways to like put this into concrete as like a patch or a fix for,
Interesting.
existing buildings? I'm wondering.
Good. Yeah. Hey, who knows? I think you're on a good track with it, saying whether or not an entire structure might be made of this fungi plus bacteria super mix is maybe, but I like your idea of either components or patches, that sort of thing. That might be more viable as a real world application for this. So we'll see.
So something to start, something very fun. And again, check out the show notes and you can find more information as always in the articles. So story number 1, very nice. Story number 2, and we're going to move to something that, an article that I had read over the past couple of weeks that kept popping up was rice. In particular, Ralph, like there's an issue where thanks to global warming trends, the environment is getting warmer, and that's leading to issues with our current crops, like rice, for instance, that produce, turns out, organic arsenic. So rice is getting more arsenic in it because of the warming climate.
Interesting.
Yeah, so like our existing crops, yeah, we could probably move them to different regions. We can grow what we have, but by and large, we're going to have to adapt what we grow to fit, where we can grow it and what we can grow. So story number 2 kind of speaks to that, and this is really nice because I was like hearing ways that we can improve people's lives just by, hey, planting something different, planting a new species, something like that. So story number 2 really speaks to that.
Absolutely. A great example of this next story of agricultural technology, which is another field that's got so many wonderful things going on all around the world. But this comes from Anthropocene magazine. The headline here is, "In the quest for crops that can thrive in a warmer future, scientists just had a breakthrough." So let's get into this. This is a good one. So, a quick reminder, and it kind of relates to what you were just saying a moment ago. Over half of the world's population relies on rice as a primary staple food. So that's the seriousness of this.
Mm-hmm.
The article discusses a major breakthrough in developing rice varieties that can thrive in high temperature environments, not just exist, thrive in high temperature environments. Researchers at a major laboratory in Wuhan province in China identified a gene called Q212 that plays a key role in how rice grains develop under heat stress.
We're just going to gloss over from a lab in Wuhan, and we're just going to continue on here. So
yeah, because
yep.
I didn't even want to try to butcher the name of the laboratory. So folks, come out to the show notes. You can see that we have a link to that lab and everything. And my comment here about this is another great example of gene manipulation in the field of agriculture. Ben, you and I've seen this over and over and over again. So many great advancements. Now that they're able to mess around with the genes of living organisms, it's really kind of amazing.
Well, yeah. To even speak to that just a little bit, I remember they, like 100 years ago, they figured out how to make like calcium enriched rice or something like that. It was a way to get more vitamins into rice through through the strain that they were growing, and that's credited with saving millions and millions of lives just because people were able to get nutrients that they wouldn't get elsewhere. No, it affects billions of people for sure.
Absolutely. And by the way, this gene called QT12 in the show notes, and this is one of the things I do with the show notes, folks. And many times in the articles, there'll be something they talk about, and I think, I want to know more, or I don't really know what they're talking about, and I inject little tutorial things. So in the show notes for today, there's a side note. You can learn a lot more about Q212, this gene in question, and we'll skip over that. We're not going to read it on air here, but you can come to the show notes and check that out. So picking up again with the story, under high temperatures, Q212 typically increases starch production at a cost of protein, leading to chalky and fragmented grains that lower overall crop quality. Well, that's what usually this gene does. However, the scientists in China discovered specific on-off variants of Q212 that prevent the negative effects of heat. So they figured out, a variant of this gene that will prevent this problem. And to validate their findings, the team introduced favorable Q212 variants into a heat-sensitive rice variety called Washan, and I hope I'm pronouncing that correct. Field tests conducted at various locations in China revealed that this new lineage produced between 31.2% and 77.9% more grain yield compared to the standard variety under the same heat-stressed conditions. Wow. I mean, that's a significant improvement. And this breakthrough holds significant promise for Asian rice farmers who often battle with declining crop quality and yield due to rising temperatures. Wow. And to wrap this thing up here, a little conclusion, the research not only opens the door to more resilient rice cultivated varieties, but also paves the way for similar approaches in other staple crops affected by climate change. There you go. Gene editing again, coming to the rescue, in this case, in the world of agriculture.
Yeah, for sure. Just, doing more with what you have is, going to be the key to a lot of the innovations that we find here. It's not even about doing something completely different or, growing it indoors in hydroponics or, having some kind of field robot that shoots lasers and destroys weeds. Ralph, sometimes it's just doing what you're doing, but doing it better and more efficiently. And that is a breakthrough all on its own. So very nice. And story number 2. Story number 3, though, we're going to go ahead and hop on down and talk about, aquatic robots, which, is not completely uncharted territory here for us on the show. We've seen a number of robots take a lot of different forms, but this one is robots generally, though, Ralph, it's generally they're like, how do they exist, peacefully with nature and, make sure that they don't, destroy fish or, kind of get in their way.
Right.
This one, I think, takes it to a new level, and a robot that is coexisting with fish as prey, which, story number 3.
Yes, this one it caught my eye. The headline here is edible aquatic robots could be eaten by fish to eliminate waste. I mean, how can you resist that headline? This comes from New Atlas, by the way. This is a really fun story. This is cool. Okay, so here we go. The article talks about if you're releasing a robot into an aquatic environment with no intention of retrieving it, the bot had better be biodegradable. Swiss scientists have gone a step better than that with little robots that can be consumed by fish when their job is done. Ha! So clever. We've already seen a number of experimental microbots that can be equipped with sensors and other electronics, then turn loose to wander the wilderness while recording and or transmitting environmental data. To your point, Ben, we've seen this many times before in other cases. But in most cases, the idea is that when their mission is complete, the tiny, inexpensive devices will simply be abandoned. With that fact in mind, their bodies tend to be made largely out of biodegradable materials. But that said, non-biodegradable plastics and toxic chemicals often still factor into their construction. So what the article is doing is setting the stage. Have we had aquatic robots before? Yes, of course. Have some of them been made with mostly biodegradable materials so that they don't harm the environment? Yes, but in most cases, the author is pointing out that there's still often chemicals or plastics involved. And That's not great.
Yeah, which I guess, thinking back to all the articles that we've done, like, in terms of the overall amount of trash and pollution that you're causing by these, select few scientists who are releasing swarms of robots to track this, that, or the other, it's probably pretty small or negligible, but at the same time, it's still damage. It's still pollution. It's still essentially littering, if they're right, if you have no intention of recapturing these things, which it never really occurred to me. So interesting.
Yeah, it definitely is. And so researchers at Switzerland's EPFL University set out to change all that scenario with their new aquatic robots. Each motorboat-shaped bot, and by the way, if you're listening to us as a podcast, please come out to computeramerica.com, because again, the show notes will have the pictures so you can see what we're talking about. So each motorboat-shaped bot is about 5 centimeters long. That's about 1.97 inches, and weighs an average of 1.43 grams and can travel at 1/2 to 3 body lengths per second. Its purpose, so it's a little tiny thing, guys. Its purpose, it's to collect data on water pH, temperature, pollutants, and microorganisms using biodegradable sensors. So even the sensors are biodegradable, which is a pretty neat trick. More specifically, their hulls are made out of commercial fish feed pellets that have been ground into a powder, mixed with a biopolymer binder, poured into a boat-shaped mold, and then freeze-dried. And here's more about how this little guy works. In the center of each robot's body is a chamber filled with a non-toxic powdered mixture of citric acid and sodium bicarbonate, also known as baking soda. Not too exotic there. The chamber is sealed with a gel plug on the bottom of the hull and connected to a propylene glycol-filled microfluidic reservoir, there's a mouthful, that forms the top layer of the robot's body. And by the way, glycol is a type of organic compound that belongs to the alcohol family. And once the bot has been placed in the water's surface, water gradually starts making its way through the semi-permeable plug. When the water mixes with the powder in the chamber, a chemical reaction occurs, producing CO2 gas. That gas expands in the reservoir, pushing the glycol out of the hole in the back of the robot. Eventually, their hulls would become waterlogged enough that they would become soft and start to sink when their job is done, when their propulsion is finished. At that point, fish and other animals could eat them. In fact, an alternative possible use for these robots is the distribution of medicated feed in fish farms. What? That's so cool.
So not just they can be eaten, but they are intended to be eaten. It's again, something that people I'm sure have picked up on is the idea of a bot or a robot. Very loose, very much
True.
the strict definition of a robot.
That's right.
But still, it's something that hopefully, even if parts of this work its way into other people's research, such as, even if like what the sensors are made out of turns into something that's biodegradable, that is a step in the right direction. So this is not the solution to everything, but hey, maybe its research can help guide other projects in the future to be a bit more sustainable. So
yeah. And Ben, I want to amplify on something you just said a moment ago that I think is so important for people to understand. When you talk about robotics, and you're so spot on with this, that's an umbrella that's really wide, embraces a lot of stuff, from little tiny things in your blood system being manipulated through magnets on the outside of medical tech robotics. Robotics can be, it's not just a humanoid robotics or robots that look like dogs or that. No, robotics embraces an incredibly wide range of manipulable or movable things. It's just kind of amazing how wide that definition umbrella is.
Yep, they could be super simple or extremely complex, but hey, they all have their uses. And now little edible motorboats, I guess, is in the robots that I now know of. Okay, story number 3, and again, check out the show notes. Very, very cool. Story number 3. Story number 4. We're going to go ahead and go to our last story of the segment that we're going to do, more of its entirety. A little bit more, we're going to talk about honorable mentions, but starting number 4, Ralph, let's talk about, well, first of all, medical, as one would assume, but let's talk about, brains and brain lesions. I can't think of a better way to end a Friday. So,
Yeah, there you go. Yeah, and friends, if you're new to the show, what Ben and I very frequently do, almost without exception, is the fourth story that we highlight is from medical technology world, because there's so much going on. It's just absolutely amazing. This story comes from Technology Networks, and it's actually leveraging a press release from the University of Virginia. And the headline here is Non-Invasive Ultrasound Halts Brain Lesion Growth. Wow, so cool. The article reports on a promising new treatment developed at the University of Virginia Health System for cerebral cavernous malformations. What's that? Well, that's clusters of abnormal blood vessels in the brain or spinal cord that can lead to serious neurological issues. And once again, I said to myself, I need to know more about cerebral cavernous malformations. God forbid I ever have it. But in the show notes, I've inserted some additional information. You can dive into that if you so desire. But rather than relying on invasive methods like brain surgery or stereotactic radiosurgery, the approach the University of Virginia came up with, their approach employs focused ultrasound in combination with tiny gas-filled microbubbles. Okay, that's interesting. When these microbubbles are activated by the ultrasound waves, they temporarily open the blood-brain barrier, allowing the treatment to stabilize the lesions without the need for incisions or high-risk procedures. Without the need for incisions or high-risk procedures. How wonderful. Interestingly, and I always love this kind of stuff, Ben, we see this time and time again. The article says, interestingly, the discovery was somewhat accidental. While researchers were conducting long-term safety studies aimed at enhancing drug and gene delivery to these lesions, they noticed that the focused ultrasound with microbubbles was unexpectedly halting the growth of these cerebral cavernous malformations. And here's another example of where we need to bow low and build a great statue of thanks to mice and rats. Okay, I've said this a million times before. In lab tests with mouse models, 94% of the treated cerebral cavernous malformations stopped growing within 1 month, in stark contrast to untreated lesions that increased 7-fold in size in that same time period. So it just blows my mind. Moreover, the treatment appeared to reduce the likelihood of new lesions forming, which could have significant long-term benefits, particularly for patients with a familial family history predisposition to cerebral cavernous malformations. Wow. And to wrap this one up, because focused ultrasound technology is already common in clinical settings, this non-invasive treatment could, pending further clinical trials and regulatory approval, become a viable alternative to current therapies, which again usually involve surgery. Wow. Again, folks, we're going to leave you feeling better about the world. There is hope if you turn to science and technology. You'll get uplifted.
No, absolutely. And even more so that you can see research in a particular field, even if it's, and this is why just generally supporting research is so important, is that, even if you don't always accomplish every single goal that you set out to, tangentially you may find a breakthrough, or find something like they did that will benefit a lot of people almost inadvertently or accidentally. So no, very, very cool. And hats off and blood brain barriers off to this research team. They did amazing work, and thank you so much for Ralph bringing these stories to us. So for everyone out there who's following along, you may notice story number 4 is not the end of the show notes. The honorable mentions are stories that we just simply don't have time for. We're trying our best to kind of keep the show to a more manageable, listenable format. And that means that some stories not worse, not less. They just don't kind of make the time cut. And if you want to find out more, head on over to computeramerica.com. At the bottom of the show notes, you'll find the honorable mentions with links to articles and everything that you need to know. But Ralph, we can at least give them the headlines, and then they can go to the go to the show notes and get more information. So yeah, headlines.
Yeah, here we go. We're going to have 4 honorable mentions. First one comes from an outlet called The Conversation, and I love this headline: How to Engineer Microbes to Enable Us to Live on Mars. Wow, it's a great article. Check it out. Very, very interesting.
Mm-hmm.
Our next one comes from phys, phys.org, short for physics.org. Microscopy method can reconstruct mammalian brain tissue in synaptic detail. Oh, yeah. This is very geeky, but absolutely fascinating.
They're
Please.
finally getting to the point where they can add to people's brains. This is going to be a great thing. It's good.
I just hope all this technology becomes available before I'm gone. I need help. Okay. The next one comes from scipost.org, another contraction of the word physics. Headline: Neuroscientists use brain implants and AI to map language processing in real time. Let that sink in. Brain implants and artificial intelligence to map language processing in real time. Oh my gosh. Amazing. Just amazing.
And just a little aside here, like when you think about the technology and, essentially think like Stephen Hawking, for instance, I think he really popularized, kind of where the technology was at the time.
Mm-hmm.
If you think about even just a decade ago, where it was to kind of get people to speak without the ability to speak.
Yeah.
Ralph, we're just a couple of years away from that just being, seeming like ancient history. It is incredible.
Yeah. Oh, it is. It is spectacular. And our last one, hey, talking about robots and the wide umbrella of what embraces a robot. And we see this in medical technology a lot. This comes from the University of Leeds, their press room. And the headline here is: Mini Rolling Robot Takes Virtual Biopsies. So another example of what is a robot. It's a pretty wide range of possibilities, but this is a really good story, again, from in the world of medical technology.
Cute little robot, has a wicked looking little arm, and yes, that arm is supposed to go inside you somewhere, but that's okay. Everyone, I want to thank you so much for tuning into the program, and Ralph, I want to thank you so much for putting this together. The show notes, as always, very detailed, and ladies and gentlemen, highly encourage you to go check those out. Once again, at the top there, we have Ralph Bond. We have a whole segment dedicated to him, or a whole section dedicated to Ralph and his segments. And of course, you can find them on all podcasts as well as on YouTube. So everyone, thank you so much. And catch us here next Friday, where Ralph joins us every single Friday to talk about 4 of these different stories. And ladies and gentlemen, have a great weekend. Do something fun. We'll catch you next time. Until then, have a good one. Bye, everyone.